Here's an independent events problem. When a student is selected at random from a high school, the probability that the student plays soccer is 18%. So here goes my Venn diagram. The probability that they play basketball is 32%. And the probability that the student plays at least one of those sports is 42%. So that means everything inside of both circles is 42%. And we want to know how much is strictly basketball, how much is strictly soccer, and how much is the intersection. So we're going to combine the addition rule and the multiplication rule to see if we can determine if these are independent events. So we know that the probability of soccer union basketball is equal to the probability of soccer plus the probability of basketball minus the probability of the intersection. This is the addition rule. And I will color code everything for you here. Soccer, basketball, intersection, and we are interested in the union. In fact, we know the union. It's the probability that a student plays at least one of these sports is 0.42 or 42%. So then we just fill in the rest of the values accordingly. And again, I'm going to translate that probability statement into the letter X so it's easier to write. And then we do the math. 18 and 32 is 50. So 0.42 equals 0.50 minus x. Solve for x, you get negative x equals negative 0.08. So 8% is the value of x, or the intersection value. So that helps us find each one of these little pieces here. This is 0.08. This is 0.10 because we need this to total to 18. And then this would be 0.24 because we need this to total to 32. Now, the second part of the question, are these independent events? Well, is the product of 0.18 and 0.32 equal to 0.08? I don't think it is, but let's use the calculator to find out. 0.18 times 0.32 equals there should be a decimal there. Well, there we go, 0.057. So the answer is no. These are not independent events because the product of S and the product of a soccer probability and basketball probability does not equal the intersection probability, so these are not independent events.